mentioned, I'm JohnHandler, and tonight we're going to be talking about Amazon Cloud Search. We have also with us Tom Hill. I'm a solutions architect on the Cloud Search team, which means I talk with customers and engage people on their search problems and try to figure out solutions and how Cloud Search can do that. Tom is a solutions architect as well. And Mike Bolig, our marketing manager, actually did not make it tonight. He twisted his back in a tragic sporting accident, but he'll be fine. We're just going to talk a little bit, give a little bit of a greeting, and then we're going to have an overview of Cloud Search. We're going to look at what is Cloud Search, how do you access it, how do you interact with it. And in the second half, I don't think we're going to have a break tonight. In the second half, we'll look at a live demo. How do you build an application using Cloud Search? Pretty much soup to nuts. So again, we're going to talk a little bit about Amazon Cloud Search. You'll hear about what that is. We will look at setting up and configuring your domain, your search domain. We'll look at how do you upload documents, and we'll look at the search interface, how do you run searches. And we have at the end additional resources. So all of this, you can find pointers to the example of all that at the end. So Amazon Cloud Search is a fully managed service that AWS is providing as a building block service in the cloud. And really what that means is you can create a search service with very simple interaction patterns that allows you just to post documents to it and run searches against those documents. It automatically scales for both data and traffic and handles structured and unstructured data. You can send structured documents in, search against fields, and it'll scale as you send documents in, and it'll scale to handle queries. It has near real-time indexing, which means there's no running a build on the side. You just send documents and they become searchable. And as you'll see, you can get up and running in about an hour. So I have these slides because I know we have a lot of search experts in the audience, but I know we also have some people who are new to search or not as familiar with how search works. So I have some slides that I'm going to blow through pretty quickly, and if you have questions, we'll take those questions at this part. So fundamentally, what search is, search operates over a collection of documents, and if you think of an analogy, a collection of documents, something like the articles that are in the Encyclopedia Britannica. Now, if I wanted to search in the Encyclopedia Britannica for US presidents, the sort of naive notion would be, okay, well, I can start in volume 1, and I can look on the first page, and I can scan, and start and go all the way through to the end to find all of the articles in there which reference the terms US and presidents. So I can do that, but that's not actually a very optimal way for me to find all the articles about US presidents. And in fact, people know this, and so we've created things called indices, which allow us to go from particular terms, not to articles usually, but to pages where those terms appear in the document. So I can look up US, or I can look up presidents in the index and get a list of pages where those articles are. Search engines work in a very similar way. We create an index out of all of the terms that we've seen in any document, and we then take those terms and look up and get the list of documents which contain those terms. Now, if I'm looking for more than one term, I can look up, say, in this case, US president. I can look up US, get that list of documents, and then I can look up the term president, get that list of documents, and I can put those two lists together. I can make an intersection, which gives me the shorter list of everything that contains both of them. As search kind of evolved and as it became part of the web, there are certain user interface features that are built on top of it that we kind of have come to expect. So among them, if I'm just getting the list of documents that match my terms, that's not necessarily the list of the most interesting documents that match my terms. In those cases, what I want to do is I actually want to have some kind of ranking algorithm that looks at all my matches and says, okay, that's the most relevant, that's the next most relevant, and ranks my matches so that it makes sense for me as a searcher. We have also included as a sort of standard feature something called faceting. Faceting is retrieving counts for values of particular attributes on a document. So in particular, if I'm searching Amazon for shirts, I may get a value like red shirts, 50,273, blue shirts, 27,452, et cetera, et cetera, et cetera. We also have range searching. So typically, if I want to search for a price in a particular range, I'm able to search from $1 to $10. I can do individual field searching. So if I want to search only for DVDs, I can actually select DVDs and then receive only the results that contain DVDs. And we have more complex combinations of these kinds of searches that allow us to do things like search for DVDs from with a price range from $1 to $10, and that have a blue cover. I don't know what. And then finally, we have more complex relevance features that involve looking at what are users clicking on, looking at crowdsourcing, looking at what's popular right now, et cetera, et cetera. So all of this is kind of the standard search paradigm. Okay, let me pause there. Is everybody sort of okay with that? We're good? Okay. So let's talk a little bit about Amazon Cloud Search. With Amazon Cloud Search, you'll create a search domain, and this will give you, basically, as I said, 3 interaction points with your Cloud Search domain. And first you'll have, I think I have a pointer. So you have a document service endpoint, and these are exposed as stable DNS entries, and they're RESTful services. With your document service endpoint, you post your documents, and they're in a standard sort of format called SDF, search document format. Then you get a second endpoint, a search endpoint, and this is again stable DNS entry, where you can use HTTP GET to retrieve search results using the URL parameters for specifying the query. And finally, we have a configuration endpoint, which allows you to configure the processing of your fields, configure language options like stemming, stop words, and synonyms, configure access controls, and other ranking and relevance functions. Now, I threw up the features overview because I'm not actually going to read all these and talk in depth about them, but I want you to get the sense that Cloud Search actually provides you really a lot in terms of features. Yes?
Sorry, I didn't want to interrupt. So, there was an API to post the document.
Yes.
How do you post the changes to the document?
Okay, we'll get to that for sure. So I was going to, it's kind of a little bit old home week for me, so I was going to stop and, on this slide, have a little bit of a story. When I was at shopping.com, we had a search engine that we had written, and this is in a million years ago in web time. This was at least 5 years ago. And we had 10 or 15 developers working on creating a search engine to do our search problem. And we had a sort of an old code base. We said, okay, we need to rewrite our search engine. And looking at that, we were looking at, say, 20 or so person years of effort to start from scratch and write a real web-scale search engine, including doing our own management of things like figuring out how much hardware to rack, racking the hardware, cabling the hardware, running different data centers for redundancy, doing all of that work, and fundamentally coming out with this list of features, 20 person years. So I want to point to that and just say Cloud Search is going to actually provide that to you out of the box, and you'll see in about an hour. So these are the steps that you'll go through to create a search domain. First, you create the domain. You'll upload documents to it. You'll configure your domain for the treatment of those documents, and then you'll integrate it with your search application. with Amazon Cloud Search, we have a console in the Amazon Web Services console. And this allows you to, at a very simple level, configure and create your domain. We also have API level interaction and command line tool level interaction. So this is just a picture of, there's a wizard in the console to create your domain, 3 easy steps, as we said. I'm going to actually, so the promised demo is going to go now. And I was hoping that I wouldn't have to peer around the edge of the thing, but it seems like I might. Maybe Tom?
Switch back to mirroring.
Yeah, I am mirroring. Okay. So, again, here's the console. And the first thing that we're going to do, we're going to, you'll see here we have a list of the current domains that I have running. We have call to action. We can create a new domain, delete a running domain, et cetera, et cetera. So I'm going to push that button. And this is the process of creating a domain. So we need a name. Oh, capital, sorry. Now, at this point, I can actually configure fields right here in the console, but I'm not going to do that yet. So I'm going to say manually configure, and I'm going to continue. And I can, again, manually configure, I can add fields, et cetera, et cetera. We're going to go through all of the different options here. I get access controls, so I can allow everyone access to all services. I'm going to do that. And start. Now in the background, we are creating a bunch of resources in AWS that will support creating this search domain. Actually, I'm going to do that. And again, in the console, you're able to upload documents. So we have a button for doing that. You're able to do it command line, and you're also able to do it direct to API. Again, as I said, I'm going to go through the configuration options. So when your documents are uploaded, sorry, I'm having a moment of technical difficulty. Let's just go ahead and talk about configuration. So your documents will be a collection of fields and values, fundamentally, name value pairs. We have, again, in the console, a simple way of configuring those. The different options you can have, we have types for the fields. Cloud Search supports natively text types, 2 of them, text and literal. Text fields are tokenized, processed, and individual tokens are put into the index. Literal fields must be matched exactly. We have integer fields. These are treated as integers and are available for range searching and modifying or relevance calculations. We have 3 different options that you can set. So you can enable search for your fields. This means that an index is created for that field, and you can search individually within that field. You can enable faceting. So with a click of a button, you can enable facet computation for any of your fields. And you can enable fields for result. So enabling field for result means that you can then retrieve the value for that field with your search results. In addition, you can create composite fields. So you can take a single field, copy its value, and along with other fields into a also set a default value, which any document that does not contain that field will get the default value for that. So again, in the console, you also have the ability to run text searches. So you can do a quick prototyping and look at the documents you've uploaded and how they search and get some results back and see them in this format. So we mentioned automatic scaling. So Cloud Search scales along two different dimensions. First of all, it's a completely in-RAM index. So as you're sending documents, the entire index is hosted in RAM for best performance in terms of latency and throughput. As you're sending documents to the document service, we are in the background tracking how much data is currently in your index. And if you're starting out on a single partition, eventually you'll fill that partition up. At that point, Cloud Search will, in the background, run a build, partition your data into two partitions, deploy those instances, and swap them into your domain. So seamlessly, you'll actually have your domain scale out to multiple partitions. So as you're sending more data, we're scaling in the background to accommodate that data. Of course, if you delete documents to the point that you would be too small for a partition, we'll actually scale you down as well. Yeah.
When the repartition happens, does it mean there will be delay in search latency?
No, the repartition happens entirely in parallel. So as we're creating the updated fleet with more partitions, that happens entirely in parallel. When it comes online, it's then swapped in behind your query load. So you just get a seamless swap.
And it's completely automated?
Completely automated. Similarly, and again, this is very in line with Amazon Web Services automatic scaling to handle what you throw at it. So similarly, we scale along a vertical dimension for traffic. As you're sending traffic to your search domain, we have a CPU trigger that says, well, when you hit a certain CPU load, then we need to add more instances of more copies of the partitions to handle that load. So we will actually scale you vertically, adding copies of the partitions to handle that additional load. And of course, this is one of the really nice features because, again, when I was at Shopping, we had to do long-range planning and try to handle provisioning for our spikes. And what this auto-scaling feature allows is that you only actually provision for and pay for, well, you don't provision for anything, but you only pay for the CPU that you actually need to handle the load that you're sending to it. Okay, so that was this is where the break would have been if we were having a break, yes.
The reason why you create a domain, why do you start with a domain?
So domain, again, is a concept where it's just the concept of a search engine in the cloud. So in using Cloud Search, you start with a domain. That's going to be your search engine.
But does that mean it only search within my data, or can it combine with my data and the web data?
It would only be the data that you send to it.
Okay.
Cloud Search is not a search the web solution. Cloud Search is, I have data that I want to search with a search engine, and I'm going to send it to Cloud Search.
I see. So it's more built into facilitating my own application, but not a more generic one.
Exactly.
Do you plan to add a crawler module to it?
So we have, various plans that we look at in terms of how to get data into it. We have some experimental tools that do things like handle PDFs and Word documents and other things like that. Crawling comes up from time to time as we talk to customers and is an interesting topic that people really are interested in seeing. I wouldn't say we're not imminently going to come out with a crawler for sure. I think there are good open source crawlers out there that you can use, and we would integrate pretty easily with them.
How about text processing? I saw a line answer there. Do you provide a way to add a piece of code to assess the data that I want to and extract keys from it?
No, we don't have anything intrinsically that would text process your sources. If you have, XML data or something like that with some kind of structure to it, you would then map that across to the Cloud Search document structure, but you would do that on your own.
So what about custom analyzers, custom text analyzers?
So we don't have custom analyzers, and we don't have hooks at the present to hook in custom analysis. So really what you would do there is you would pre-analyze and then pre-tokenize and then send it in that format.
And when you have the partitions, shards, whatever you want to call them, for your index, do you know the routing, or can I, if I know actually that my document is in a particular shard, can I actually route it myself?
So our philosophy is to provide the simplest possible solution. So we don't expose internals like where are my partitions at or all of that. This allows us to do nice things on the other side, which, for instance, do the load balancing for you across multiple, as it gets wider and deeper, we're able to route traffic correctly so that all partitions are responding and et cetera. We don't expose those levels. So it's really, again, a single DNS entry where you send a GET. And then the magic happens behind the scenes.
So how do you ensure that, the index, the new index is created is valid without a QA being testing it? And a lot of things can go wrong there.
Sure. One of the nice things is it is sort of low barrier to entry to be able to create one of these domains. So if you're talking about, okay, well, I have my project running, and I'm going to now make some configuration changes, or I want to change my UI, and I want to, do some new features, then it's very easy to create a domain in parallel that supports the new feature and then migrate that to your existing domain. As you're sending updates, so that's the case where I'm going to create something new or different. There isn't a point precisely where you would QA, I've sent 50 updates and I want to make sure that those updates were the right updates.
So if you're partitioning the data, how do you ensure that the new index is good enough to roll over and replace the old one?
Well, so I think there's a couple of questions in there, but I think fundamentally we have, the code that we wrote ensures that as the hosts come up, they have all of the data on them and they're ready to process requests, right? So that's sort of part of the heart of the code that we wrote, was to make sure that that swap happens correctly.
Is it fair to say this can compare with Google Enterprise Search or Bing Enterprise Desktop Search?
Yeah, I mean, I think you'll see some similarities and some differences, right? And I think what Cloud Search's strength really is, again, in ease of operations, being a turnkey solution, and I think also in terms of pricing. So we really wanted to be very disruptive on the pricing. So I think our pricing model is very simple, and you can get started for less than $100 a month with a fairly large problem.
I have a question on how you can adapt to the change of your data. Let's say I build a startup for, let's say, Diablo 3 auction house, and the items sold on the auction house in this net game, let's say if it's a Thanksgiving, there are a bunch of items sold now. So the data actually will fit in. Let's say initially I just have 2 gigabytes of data. So I use your API to feed into your search engine. Let's say all of them are JSON format. And then let's say today is Thanksgiving, there are a bunch of old people playing Diablo 3, and then now there are 20 gigabytes data. Just jump through this afternoon. And then tomorrow it's become like 1 gigabyte again. So how you adapt to this? Let's say when 2 gigabytes become 20 gigabytes, so you have to scale from, let's say, 2 machines to maybe 20 machines. But how fast can you scale your machine?
Yeah, it's an excellent question. So first thing to say, of course, very dependent on your data and your configuration. And we don't have, per se, an SLA in terms of how fast can we scale out. Most of the time, it should be in the 1 hour range so there's a couple of different points in there. How fast it scales, it has capacity to handle updates up to a certain point and it actually triggers a build long before it's actually full, right? So it should scale seamlessly without you actually seeing that hour delay there. It's already going to be scaling as you're tripping over the end point of what it can handle handle in the instance that it's currently on.
But I mean, like, you got 18 gigabytes additional data, and you have to index this 18 gigabytes within very quick. Otherwise, the items sold in the auction house won't be actually searched out, because like you play Diablo, then the items you want to search in 5 minutes. And if you cannot index that quickly enough, then you cannot get it out.
Absolutely. I mean, the system definitely has, you know, a limit in terms of how quickly it can shove data through. And I can't tell you what the limit is without having the actual data configuration and all that stuff, right? It's built to be responsive and scale well in as many situations as, of course, as we can.
So you're saying your data structure, how similar is to JSON, like say standard JSON format? You're saying we need to feed in the data into the Amazon Cloud Search format, right?
Yes.
So what's that format? Is that general
Right,
like
so
JSON?
I'm glad you brought that up. Let's go ahead and move on a little bit into the example, and we'll get a sort of a more grounded view of sort of how the system works and what you feed to it. So for this demo example, we are looking at the million song data set, and this is a publicly available data set of song titles, along with quite a bit of rating information and other numeric information about those songs. And so we're going to take that, and we want to construct an application that can be, what we imagine is somebody is looking for sort of important songs that happened at a particular time in their life, something like I was getting married, and I remember I had all these songs that were like my favorite songs, and it's my anniversary, and I'm going to give my spouse a present, and so I want to build a playlist and buy that playlist and burn it off. And so we are going to use the million song data set to support that kind of application. And of course, since people are searching for songs, we're going to definitely have the artist name and the title as available as search fields. And we also want to have the year so that people can go and say, oh yeah, it was, you know, I got married in 1980, whatever it was, it wasn't, but oh boy, now I'm going to be in trouble. 2004. And we're going to put genres in there so people can do narrowing, and we'll also put a familiarity number in there, which will help us sort better and move familiar artists closer to the top of the list. So we're going to use this to build a web application that will look like this. And you know, we're featuring sort of standard search stuff on our start page. We have a big search box. We have some faceting that we can do here. And we're searching for songs. And let's just pop to a quick live demo. Demo that. Pick the right tab, even though I can't see them. There it is. Okay. Anybody got a favorite song? Favorite artist?
Rolling Stones.
Rolling Stones. Okay.
Oh, man.
And after my own heart. So we can search for Rolling Stones. You'll know we have a cute little UI
Spears, but
trick. You want Britney Spears and Rolling Stones? I think the intersection is no for that. We have a cute little interface trick we do where we pop up different genres. We can search for Rolling Stones, and we can see sort of a standard kind of result list. And again, we can use facets over here to narrow. We get, again, Rolling Stones. We get Under the Boardwalk. Interesting. So this is, again, sorting by relevance. But if we actually add in a little notion of familiarity and resubmit that,
there's a question.
we should see some more. Yeah, we see the Rolling Stones kind of come up more towards the top. Okay, so this is, again, I'll get to the question in a second. This is just basic user experience stuff. This is kind of how we want our application to go. Okay, question?
So those facets, were they pre-configured?
No, they're computed. So looking back.
How do you decide what to facet on?
Well, that's part of the search application, yes.
Okay.
So which facets we're showing in the right rail At the moment, those are hard-coded. We're just showing basically what we got, right?
But your schema indicates which ones are going to be
Yes,
there,
in the schema, you can set which fields are actually available for faceting. And we'll actually dive pretty deep into search API, so we'll show you how you can write your queries to retrieve facets for different fields.
You sorted by familiarity. Was that a computed field or was it a field in the index?
Yes, we're going to get to that one. Okay, so again, a view of our console showing this search domain here. I named it Million Songs. You can see actually it's somewhat of a misnomer since there are 792,000. We have the number of fields we've indexed. We have the number of instances that are currently running for our domain. We have the number of partitions that are currently available for our domain. And then we have the endpoints where we can send documents and queries. And we're able to do various actions over here. Again, we have the ability to run a test search. We have access policies that allow us to control the access to the search endpoints. We have indexing options, which we'll go into, and rank expressions, which we'll also go into, and then text options, which are, again, stemming, stop words, synonyms. So create a domain. We actually walked through that, and I wonder if our domain has come up. Usually it is about 20 minutes to go from the command to create a domain to when the domain is actually up and running. So exactly. So we now have a search engine that's all up and ready for us to configure it and send documents to it. And just point out again, we also have command line tools that allow us to perform a lot of the actions, actually a superset of the actions we can perform in the console, we can perform from the command line. All of this is so scriptable, and the API level calls allow you in a deeper level of scripting. So let's look a little bit at what SDF looks like. So this is a single, well, the first thing to say is SDF, this is JSON, and SDF documents come in batches. So we have an array of individual search documents. Each search document, I thought I had a build for this. Wait a minute. Sorry. Oops. I did. Search documents come in two flavors, adds and deletes. If you send an add, well, the document has sort of a block of identifying information. So there's a doc ID, which must be unique across your documents, as well as a version in a language. We have, again, adds and deletes. If you add a higher version number of an existing document, that version will overwrite what you have. So we handle updates through adding higher version numbers. Again, adding and deleting as well is handled through version numbers. So Cloud Search will always serve the highest version number of any document that you send to it. Then we have a set of fields. As I said, these are name-value pairs. So you can see here's the title, and it's Cajun Twisters. And we have a number of those. We also have, here are the familiarity field. I wanted to highlight that because that's going to come back as we rank by familiarity. We're going to use that number from this document in our relevance calculation. And we have genre. And here, Cloud Search allows multiple values for any field. We can specify multiple values as an array of individual values.
So the version, does the client need to specify the version?
The client specifies the version, yes. And typically what we say is, a good thing to do is to put the timestamp in there as the Unix epoch. If you're running updates from a single host, that's completely non-problematic. When you get multiple hosts, then you have to deal a little bit with clock skew. But by and large, putting a timestamp in there means that every time you send an update, you'll be sending an update. Right?
What was the reason behind it? Isn't it much easier to have a common ID? And if you send another document with the same ID, you overwrite the document, thereby sending the document back.
So that is easier. However, we have multiple hosts on our side, and potentially you have multiple hosts on your side. So there's a sequencing problem. If we receive 3 updates for the same document, we can't necessarily apply them in the order that we receive them. So we allow our clients to specify a version number to allow them to disambiguate which is the intended latest version.
So you would queue it in your site before
Right.
committing it.
And it becomes searchable in what's called eventually consistent manner, which means that if you send version 5, 6, 7, and 8 at the same time, you may see version 5, 6, and 7 for some short time period, but eventually you'll see only version 8.
Is there a way to provide any security information in this format?
Depends on how you mean. So
I want this to be seen by only this kind of privileged holders.
sure. So that's generally speaking, that would be an application level kind of security. So within the document, you would specify either users or groups who have access, and then in the query, you would specify which user or group you were querying with as a filter.
Okay.
And that would only retrieve documents for users or groups that had access to those documents.
Okay.
So there's no inherent in cloud search integration with other, security kind of portals like LDAP or anything like that.
Yeah.
So you have language in
Oh,
there.
one
How do you use language?
So at the moment, Cloud Search supports natively English, and we will, as we roll out to more regions. At the moment, we're only in U.S. East, so we're in Virginia. As we roll out to more regions, we'll support more languages natively. So fundamentally, like at the moment, that's a hook for supporting
Do you also plan to do translation? in there?
translation. How do you mean?
So like you have a page in Spanish, let's say, but you translate the content in English and then do a search on that.
So the purpose of the language field is to specify what the language the document contains is in terms of the text processing that's performed on that document. Most specifically, tokenization. For instance, in Asian languages like Chinese and Japanese, you have a segmentation question where tokenization is not white space based. So the purpose of the language field is to specify how the text of the document is processed and how the text of the query is processed. So who has-
Yeah, I was just curious about any notion of keeping older versions of documents around.
So we don't expose in any way older versions. So there's only the version that you can retrieve, which is the highest version of the sometimes we do hear that people are interested in being able to look back in time. I think there's a little bit of a trade-off. Search engine is not a database, and it's not really meant to be a system of record, right? It's really meant to be derivative. And so that's probably not something that we would offer natively, a way to go back. People also want to know, can I pull all of my documents out of Cloud Search? And the answer is generally no. If you have result-enabled fields, you can pull values for your fields. It's not a great way to use the search engine, though. Okay. So we already walked through this, and I was looking confused because I knew this slide was in here twice. But we'll just look at it again. Here's looking at our config. We've taken our SDF, and we have a field per field in our document. And again, they are configured kind of as you'd expect. Our artist name is text, and that's because we want to be able to search for Keith in Keith Richards, right? So we want to parse up Keith Richards into those two tokens. And we have a genre, which is a literal, also faceted, so we can facet on our genre. We have the song ID, title, and year. Those are song ID is text, title is text, and year is integer. And I don't think we've done anything fancy here. I've kept most of the fields as result, because really that's better for debugging. It's easier to pull it out. It's easier to see what's happening when you pull out the values. Generally, you do not want to actually enable result, because again, we're an in-RAM index, and everything goes into RAM. So if it's available for result, it's going to grow your index much larger. So generally speaking, not a best practice. Pick through those.
Quick question.
Yes.
Do you have any max limit on the length of the data can be passed to the indexed column?
Yes. So a single SDF document. So a single batch of documents is maximum 5 megabyte, and a single document within the batch is maximum 1 megabyte. There's no limit on the length of the value for a field. So up to the 1 megabyte that you have available for that document, you could make it a single field, minus the JSON extra stuff.
How much for a text? Is it 5 MB? For the
So
text?
for a batch of documents, it's 5 megabytes. And then for a single document, it's 1 megabyte within the batch.
So if I want to upload document, it's 10 MB.
Right, you'd have to split it.
Split it.
Yes.
And how would the metadata? So how would it turn into the search results? Would it be like 5 results in search results?
So the first thing to say is frequently it's pretty infrequent that you get a 10 megabytes of text document, right? Even if you look at large PDFs, if you strip out just the text, you're really only talking a couple hundred K. But if you had 10 megabytes of text, and if you think a little bit about the search experience, so something like Amazon search inside the book, right? You want to find the page. You don't actually want to know that you matched the book, right? So cutting things up actually provides better search experience. You would have to do that yourself. So you would have to take that 10 megabyte, split it into pages somehow, in a way that made sense. Like if it was a big book, each chapter or each page would be one search document. And then you could repeat the metadata on each of those documents.
Is there an option to collapse them on a particular field, say book?
So we don't have roll-up as a feature right now. That's an excellent feature, and it's a little bit complicated to bring it to market in a way that makes sense to everybody.
What do you mean by roll-up?
So if I have, on Amazon, if I search for a shirt and I have 7 different SKUs for that shirt, all different colors, actually in my search results, I'd like to see only one of those. I'd like to roll them all up into a single result. So we can support that internally. One thing I haven't said is the core engine is actually the Amazon.com product search engine. So the core technology actually powers Amazon.com. And we have sort of an internal ability to do that kind of thing. There's a question of how to bring that to market, like I said, in a way that makes sense for people and is not overly complex.
I mean, you would like to be able to specify a collapse field, and that could be, or a composite field, whatever, and then have a collapse and give you that. And the quick and dirty way is just to take the first value you see and go with it. Don't try to create an array out of the items that are different. That might be something.
Right.
And then, of course, there's the other option is doing duplicate removal, which would be another reasonable approach to getting something similar done. It doesn't actually collapse, but it just gets rid of, it takes one of them and gets rid of the rest of them.
Right. Turns out it's a complex, I don't know your particular background, but it's a very complex problem to do and also to keep all the counts correct.
Right. Oh, yeah, their counts are wrong.
So, and the way to expose which is the collapsed field,
Right.
because actually that has a lot of ripple effects in terms of how the data is deployed.
Mm-hmm.
So, like I said, we hear that a lot. We'd like to have that,
Yeah.
but what we need is some time to study how people want to use it.
Right.
And then really come out with something.
What about compression, index or storage compression?
So
Any support for, because we were talking about the size
Mhm.
that you could dock with API.
So can you send in TGZ or something like that? At the moment, we only support uncompressed.
I mean, you would write your own service interface, right? You would have the ability to store, like in the Amazon cache or whatever you want. You could store the larger data items, and you could just take the key and look at the value on the way out. Because storing in a
Yeah.
search index may not be useful.
Right.
Storing it in a blob store that you do as a post-processor might be more useful.
Right. Yeah, and you're pointing to sort of a best practices thing where fundamentally you don't want to put any data in your search engine that you're not searching.
Right.
And generally speaking, best practice is to have your search here, your storage of record over here, look up, get an ID, and then pull the actual record of the item to display it. So I think that was going towards compression.
Right.
We don't support compression on the way in. Ultimately, we probably would want to, only because some of the document size limits are related to transmission time and the ability to hold an HTTP connection. So, but we don't right now. hotkey with configuration. So let's talk a little bit about ranking. Cloud Search provides rank expressions. These are named functions that are computed for each of the documents in your match set and are available for ranking your documents. They have a syntax which is very reminiscent of JavaScript and includes many of the functions that you would find in JavaScript, including powers, logs, arithmetic operators, ternary operator, all kinds of stuff. And you can create an expression, arithmetic expression, based on both, here in this case, text relevance is an internally computed field that's surfaced for each document, and artist familiarity. So what we've done is we said, okay, well, our custom ordering is going to be the text relevance plus the artist familiarity times 0.5. You can arbitrarily nest and create expressions to any level to control or to create ranks for your data.
If I upload a bunch of stuff, I can see what you computed for different documents.
Yes, you can add these as return fields, and you'll see the value you got for it.
Is there a way I can recompute it? How would I see what was the weight that is associated with artist familiarity for me to give the right value for the boosting factor?
Well, you can return the artist familiarity with your search document, and looking at it, come up with an arithmetic expression that makes sense.
Does it give a split up of these fields at X value, and finally, if you add them up, you get the final score that is returned as a rank score?
So again, you can retrieve these, you can return these with your search results and see what the value was for each document. If you're talking about debugging.
Yes.
So you can do that for debugging. For creating the function, it's more a process of data analysis on your side to say, what is the range of values that I expect in that field, and how can I scale that to make sense? Now, the text relevance function that we provide ranges 1 to 1,000. So that gives a sort of range to scale anything else to that sort of value, or not use it.
You don't provide any statistics on, like for my data, maybe all of your text relevance scores are clumped at like 2.
We do not provide statistics.
So do you compute text relevance on the entire document, or can I just compute relevance on certain attributes and apply different weightages?
Yes, so as we'll see in the search API, there's 2 different kinds of searches. If you do a fielded search, the relevance will be related to that field, right? So yes, having said that, at the moment we don't have a feature that allows you to relatively weight fields against one another, so you can't actually boost the title with respect to the description. That's a very, very highly asked for feature, so probably we'd come out with that. Okay. So we talked a little bit about building. If I make a change, and I'm going to do a quick change. So if I take this domain and I leave myself way over, am I hitting the indexing option?
Yep.
Okay. So let's just go ahead and create cast field, and it can be typed. We can make it a literal field, and again, we can choose to have it be searchable, in which case it would have an index, or not searchable, in which case there would be no index and you couldn't search it. But you could facet it, and we actually can both retrieve it and facet it. So I can create that field, and I'd say, okay, yes, I'm sure I want to make those changes. Okay, and once I've done that,